Okay, guys, and so the hydrate formula enrichment podcast, and so hydrates are actually not too difficult. They go along very well with the empirical formula. Matter of fact, we can use pretty much the same steps with slight modification to it. Um, let's define what a hydrate is first of all. A hydrate, if you think about the word hydrate, if you're hydrated, you have water. If you're dehydrated, you don't have water. So hydrates involve water. Hydrates are ionic compounds in which water has bound itself within or inside the crystalline structure in a set ratio. So the ratio is defined. And effectively we have inside an ionic compound which forms these large crystal lattices. We have water molecules bound within that, and we know what the ratio of those water molecules are. Formulas are written simply as the formula of the compound with the addition of a little circle, a time sign, sometimes you might say in math class, and a number, which we'll put an X there for now, a number of waters. So how many in this ratio, how many waters, that's what that X is for. And the dot is just a connector between the compound and the water to say that these are together, not separate. All right, so let's do some naming of hydrates and writing formulas of hydrates. So here is a hydrate. So once again, you can see that there is a connector between the compound and the water. So that means that these two things go together. And so this is a hydrated compound. And so how do we name hydrates? We simply just name the compound like we would name any other compound. And so what would we name Na2SO4? Well, Na is an ionic compound, so we're going to do regular old plain naming. So Na is sodium. And then the SO4, that's the sulfate molecule. Or sorry, sulfate polyatomic ion, not molecule. And then we're going to name that as hydrate. And we're going to need to say how many hydrates there are. And since there's no number here, it's understood that there's a 1 there. And so the prefix for 1, you know what that is. The prefix for 1 is mono. So this is sodium sulfate monohydrate. That is how you would name that compound, sodium sulfate monohydrate. All right, let's do another one. Let me clear that space out. So LiNO3 dot, so that's the connector. That dot means this water is inside of the lithium nitrate. And so let's name it. Again, these are all going to be ionic compounds. You're just going to simply name them, the real simple naming system, plain Jane. So Li is lithium. NO3 is nitrate. And then how many hydrates do we have? We have 3. So that's going to be a trihydrate. Lithium nitrate trihydrate. And then lastly, let's go from a formula from a name to a formula. And so nickel Roman numeral 2 nitrate hexahydrate. So what does hexa mean? Hexa means 6. And so let's write the formula for nickel 2 nitrate. The 2, Roman numeral 2, means we have a 2 plus on the nickel. The nitrate is an NO3, and that's a 1 negative. So when you crisscross your 1 and your 2, you're going to get Ni1. And then we'll have nitrate, and we have 2 of those. And then hexahydrate, we need to connect it with the bullet point, if you will, 6H2O. So that's nickel 2 nitrate hexahydrate. So that's how you name nitrates, and that's how you write the formulas of nitrates, and this is how you recognize nitrates. So again, the compound, water, and a connecting bullet point to connect the two together. So as opposed to, it would not look like this, Na2SO4 plus water. That would be, this is separate, and they're going to chemically react together. It's a bullet point. Okay? So how do we calculate the formula of a hydrate? It's very simple. What we have to do is we have to figure out how much of the hydrate is the compound and how much of the hydrate is water. And so if I had some lithium nitrate trihydrate, okay, and if I know the mass of this whole thing, what I'm going to need to do is I'm going to need to drive this water away. I'm going to need to get rid of this water. So let's say I had the mass of this whole thing and it weighed 30 grams. And then to drive water away, usually all you gotta do is heat it, because water will evaporate when you heat it. And so if I heat this substance and I weigh it after I heat it, and the water would all be gone. So then I would just have lithium nitrate. And let's say that the lithium nitrate weighed, I'm just making up these numbers here, 14 grams. So how much of this 30 grams was water? Well, if the lithium nitrate is 14 grams, then the water must be 16 grams. And so that's the foundational step. And then once you have these grams, we're going to go through the same steps and find an empirical formula. We're going to convert grams to moles, and then divide by small times to a whole. That little three-step sequence. Although we will never need to times to a whole in this hydrates, because it's always going to be a whole number when you're finished with the second step. But we start with the anhydrous, so that's a word that's in your vocab list. Anhydrous, that would actually be this right here. It's without the water, and this would be the hydrated form up here. So if you know the hydrated form, the weight of it, and you know the weight of the anhydrous form, then you know the weight of the compound, and you by default know the weight of water, because you would subtract the anhydrous form from the total weight to get the weight of the water. And that's what you're going to need to do to solve these problems. So let's do an example. So what is the hydrate formula of a sample of cobalt 2 chloride hydrate that weighs 25.00 grams? After heating, it has a weight of 14.34 grams. All right, so what this is saying is that you have some cobalt 2 chloride, so that'd be CoCl2 hydrate, and we don't know what the hydrate is, so we're just put the X there, what number goes here. But this whole thing with the water weighs 25 grams. And then after it's heated, it weighs 14.34 grams. Well, after it's heated, all we're going to have left is the CoCl2. So that's 14.34 grams. If the total was 25 grams and the CoCl2 is 14.34 grams, then how much of it was water? Well, you take 25 minus 14.34, and that would be the mass of water. And it ends up being 10.66 grams. These are the numbers you'll start with, and you'll run through the empirical formula steps. But instead of having individual atoms, we now have compounds. So let's do that. So 14.34 grams of CoCl2 and 10.66 grams of water. Okay, so the steps are grams to moles, so convert the grams to moles. So in that, we're going to put the mole on top, a mole of CoCl2 on top, and a mole of water on top here. And then we need the molar masses. Cobalt's molar mass is right here, 58.993. Chlorine, right there, 35.453. The hydrogen, 1.008 or 1.0079. The oxygen, 15.999. You'll probably have those two memorized by now. And so if we add up the cobalt, 1 cobalt and 2 chlorines, then we end up with a molar mass of 96.989 grams. If we add up the 2 hydrogens and the 1 oxygen, we get a molar mass of 18.0148. Okay. Do your math. 14.34 divided by 96.989 gives you 0.148. That's moles. 10.66 divided by 18.0148 gives you 0.592. Okay, so Mass to moles, divide by small, so the small one here is going to be the 0.148, and that's going to give you 1 here, and when you divide 0.592 by 0.148, you get 4 there. Alright, so what does this tell you? Well, this tells you that for every 1 cobalt chloride you have 4 waters. And so this is a cobalt chloride tetrahydrate. That's the formula of this hydrate. So it's really very, very similar to empirical formula, except you are using an entire compound. You're using the anhydrated form of the compound and then the water that was in the hydrated form. You just need to know how much those two masses are and then do the same steps. And that's it.